Hello everyone, welcome back in part 2 hybridization series. Let's take it further with advanced cases and applications. If you have not watched part 1 yet, I recommend checking it out first so that today's concept will be clear. The link is in the description box. In previous video, we have learned about sp hybridization, sp² hybridization, sp³ hybridization and dsp² type hybridization. Now we will start with the hybridization with d-orbital involvement. So we will start with sp³d hybridization. So what is sp³d hybridization? It happens when one s, 3p and one d orbital mix. This will form 5 sp³d hybrid orbital. These orbitals arranged themselves in trigonal bipyramidal geometry. Like here, we can see involvement of 1s, 3p and 1d orbital leads to 5 sp³d hybrid orbitals. That leads to the geometry trigonal bipyramidal, like this. The bond angle between axial and equatorial position will be 90° and the angle between the equatorial position will be 120°. Like here I am showing the example of phosphorus pentachloride. In phosphorus pentachloride, phosphorus has atomic number 15, which has electronic configuration like 1s2, 2s2, 2p6, 3s2, 3p3 and 3d0. So valence shell has 5 electron. It is like 3s orbital has 2 electron, 3p orbital has 3 unpaired electrons, and this is the 3d orbital. This is the ground state of phosphorus, and it needs 5 unpaired electron to react with 5 chlorine. So on excitation, 1s electron will go in the 3d orbital of third shell, and the configuration is like 3s1, 3p3 and 3d1. Now this is 3s, 3p and 3d. Now these 5 orbitals mixes and form 5 sp³d orbitals, hybrid orbitals. These hybrid orbitals overlap with 5 p orbitals of chlorine, because in case of chlorine has atomic number 17. Its configuration is like 1s2, 2s2, 2p6, 3s2, 3p5. So we can say in the valence shell there is 7 electron. This is like 3s has 2 electron and 3p has 5 electron. 1, 2, 3, 4, 5. So we can see there is only one orbital which has one unpaired electron. So this orbital overlap with the 5 hybrid orbitals of phosphorus and develop the formula PCl₅, which has trigonal bipyramidal in shape. And the angle between the axial and equatorial will be 90° and the angle between the equatorial position will be 120°. Next is sp³d² hybridization. It happens when one s, 3p and 2d orbitals combine. Like here in this picture, you can see one s, 3p, px, py and pz and two orbitals of d like dx square minus y square and dz square. So total 6 orbital combine to form sp³d² hybrid orbital. 6 hybrid orbital. 6 hybrid orbital. These orbitals arranged in an octahedral geometry for maximum separation. Like here we can see in sp³d² hybridization, 1s, 3p and 2d orbital combine to form 6 sp³d² hybrid orbitals, which has octahedral geometry and the bond angle will be 90°. Like here I am showing the example of SF6. In SF6, sulfur has atomic number 16. Its electronic configuration is like 1s2, 2s2, 2p6, 3s2 and 3p4. This is the ground state of sulfur. So we can see valence shell have 6 electrons. So it is like 3s which has 2 electron, 3p has 4 electron and 3d, in 3d orbital there is no electron. These are empty. So here we can see that sulfur needs 6 bonds but has only 2 unpaired electrons. So on excitation, one s electron and one p electron will go in the 3d orbital of third shell. So on excitation, the configuration is like 3s1, 3p3 and 3d2. Now 1s, 3p and 2d orbitals rearrange themselves and will form 6 sp³d² hybrid orbitals. These 6 hybrid orbitals overlap with 2p orbital of fluorine atom and form 6 equivalent sulfur and phosphorus sigma bonds. That leads to octahedral in shape. So this is one of the example of sp³d² hybridization. Next hybridization is sp³d³. It is formed when 1s and 3p and 3d orbitals combine. This gives 7 sp³d³ hybrid orbitals, and these hybrid orbitals arrange themselves in pentagonal bipyramidal geometry. Like here in this picture you can see this is pentagonal shape and there are 2 axial positions. So 1s, 3p and 3d orbitals combine to form 7 sp³d³ orbitals, which has pentagonal bipyramidal geometry. And the bond angle between the equatorial position is 72° and the axial and equatorial position, the angle will be 90°. Like here, I am showing the example of IF7. In iodine heptafluoride, the central atom is iodine. Its electronic configuration is like krypton, 4d10, 5s2 and 5p5. So here you can see there are 7 electrons in the valence shell, and iodine needs to form 7 bond with 7 fluorine atom, and for that these 7 electrons are promoted to d orbital of fifth shell. Like here in this picture you can see that one s electron and 2 p electron are promoted to d orbital of fifth shell. So in excited state its electronic configuration is like krypton 4d10, 5s1, 5p3 and 5d3. Now 1s, 3p and 3d orbital rearrange themselves to form 7 sp³d³ hybrid orbitals. Now these hybrid orbital overlap with the 2p orbital of fluorine atom. In case of fluorine, its atomic number is 9, so its electronic configuration is 1s2, 2s2, 2p5. So there are 5 electrons in p orbital, 1, 2, 3, 4, 5. So here you can see there is only 1 electron which is available for bonding with iodine atom. So this p orbital overlap 7 sp³d³ hybrid orbitals of iodine and form the molecule iodine heptafluoride, and its geometry will be pentagonal bipyramidal. Like here you can see there are 5 fluorine atom are in one plane, 3, 4 and 5. So these 5 fluorine atom are in one plane and 2 fluorine atom are in axial position. These 5 fluorine atoms are 72° apart and 2 fluorine atom above and below the axial plane. Iodine heptafluoride. Here is a flow chart of all type of hybridization. We start with sp hybridization, which is formed by 1s and 1p orbital giving linear shape like in BeCl2, CO2, C2H2, cyanide ion and azide ion. So these are the examples of sp hybridization. Next is sp2 hybridization, where 1s and 2p orbital gives trigonal planar arrangement as in BF3. Another example of sp2 hybridization is AlCl3, SO3, etc. Then we have sp3 hybridization, which involve 1s and 3p orbitals. This gives tetrahedral arrangement as in methane, carbon tetrachloride and C2H6. Now moving to d orbital involvement, like sp3d hybridization, which gives trigonal bipyramidal geometry, sp3d² hybridization, which gives octahedral geometry, sp3d³ hybridization, which gives pentagonal bipyramidal geometry. And here in this row, I mentioned the bond angles. So that's all for today's session on hybridization. I hope the concept we covered are now clear to you. But remember, this is not the end. There is still more to explore in upcoming videos. We'll continue with Vesper theory and explain sp3 hybridization in methane, ammonia and water. So don't forget to watch. Bye-bye.